Okay, so today we have 4.5, and we are going to be translating descriptive form of parabolas and working with domain and range. So first we're going to be talking about parabolas and how we can take a parabola in vertex or descriptive form. It means the same thing. So descriptive is the same as vertex form. And shift the parabola around on the graph, and then we're going to be able to write a new equation. So when we're talking about shifting graphs, I made a chart for all of you to kind of help you out a little bit. If we are shifting the graph up, that has to do with the y values, and you're going to be adding to the y value of the vertex. And that is not from when we list the vertex, but when we're looking at the equation of the line, or of the parabola, I mean. If we're shifting it down, we're going to subtract from the y value. So up and down has to do with the y value, and it's pretty much going to be working the way that we expect it to. Where things change a little bit is when we're shifting right and left. So when we're shifting right and left, if you're shifting to the right, you're actually going to end up subtracting from the x value. And that has to do with in the descriptive or vertex form of a line, which is y equals ax minus h squared plus k. Because that h is a minus h, when we're moving the graph to the right, we're going to end up subtracting because of that negative right there. And so then when we shift to the left, that means we're going to add to the x value of the vertex. So when we're working with shifting up and down, everything pretty much behaves as normal because it's a plus in front of the k. But when we're shifting right to left, everything behaves a little bit differently. And one hint I have for you is that if you sketch the graph, it might make it easier to see what it is we're doing. So I always just do a little sketch of the graph. It doesn't have to be super accurate, just so that we can see what it is we're doing. So example 1, I have the equation if y equals x squared plus 6, and it's shifted down 3 units. What is the new equation? So basically, you have a, your graph is here. We're going to do a quick sketch. The vertex of this graph, this is the same as y equals x plus 0 squared plus 6. So your vertex is actually at 0, positive 6. So it's somewhere right here. So our parabola looks something like that. I want to shift it down 3 units. So it's going to be somewhere right here. So we're going to take our equation, and since we are working with down, that means we're working with the y. So that's the same as plus 6, and this plus 6 is the y. So we're going to subtract 3 from that. So that's going to give me a new equation of y equals x squared plus 3. And that is my new equation of the parabola. Example 2, if y minus 3 equals 2 times x plus 5 squared, and it had shifted left 3 units, what is the new equation? Well, first of all, this equation does not look like what we've been working with before. That number has to be on the other side. So let's add 3 to both sides first, so that we can get an original equation that looks like what we're used to working with. So that's going to be y equals 2 times x plus 5 squared plus 3 goes on the outside. So I'm shifting to the left 3 units, and our chart up at the front, or at the top, said that if I'm shifting to the left, I need to add. And when we look at that, the vertex here is -5, +3. So that's somewhere here, and our graph looks something like this, our parabola. And we're shifting it to the left. So our new parabola is actually going to be somewhere right here. So that means I need to add to the x because of that negative. So this is going to become y equals 2 times x plus 5. And since what's inside the parentheses is the x-coordinate of the vertex, that's where we're going to add 3. So let's add 3. And then we get to keep squared, and then we get to keep that plus 3. It just comes straight down. So my new equation is y equals 2 times x plus 8 squared plus 3. And when we think about it, that new vertex is actually -8, +3. And over here is somewhere close to where -8, +3 would be. So even though we're adding to this coordinate, because we take the opposite of what's in there, we're actually end up moving it to the left anyway. Example 3, if y equals x squared is shifted 3 units to the right, what is the new equation? Well, y equals x squared definitely doesn't look like anything we've worked with before, but we do know how to rewrite this. This is the same as y equals x plus 0 squared, and then we can add the plus 0. So we can put the zeros in. The vertex here is easy to find. It's just 0, 0. So if I were to do a sketch, my vertex would be right here, and this one is going upwards. So that's what my original parabola looks like, but I'm shifting it 3 units to the right. So I want my new one to be over here. So shifting to the right means I'm working with the x-coordinate of my vertex, which is right here. And our chart up at the top tells us that when we're going to the right, we're actually subtracting. So this is going to be y equals x plus 0 minus 3 squared plus 0. And that's going to give me an equation of y equals x minus 3 squared, and we don't have to add that plus 0. So this is my new equation. Example 4, if y minus 3 equals 1/3 times x plus 2 squared and is shifted 4 units down and 3 units to the right, what is the new equation? Well, just like in example 2, let's move that 3 to the other side so at least it looks like what we want it to do, or what we want it to look like. And that's going to give me y equals 1/3 times x plus 2 squared plus 3. And the original vertex of that parabola is at -2, +3. So when I sketch that, it's somewhere here, and it's going up. And I want to shift it 4 units down and 2 units to the right. So I actually want to move my vertex, or my parabola, somewhere that way. Now this is a total sketch, and it's I'm not saying it's accurate in any respect. So it's just kind of for us to visualize what it is that we're trying to do. So that's going to give me y equals 1/3 times x plus 2, and since this is the x-coordinate, let's look at shifting to the right. Shifting to the right means I subtract, so that's going to be -3 squared plus 3, and that's the y coordinate. So let's look at the shifting down, and that's 4 units down, and our chart tells us that down means we get to subtract. So the up and down, or the y-coordinate in general of parabolas, move or behave exactly like we expect them to. The x-coordinate is the opposite of what we expect. So that's going to give me an equation of y equals 1/3 times x minus 1 squared minus 1. And that's your new equation. So as long as you follow the chart and write it all out, you should be fine on all of these problems. Sketching does help a little bit, and it especially helps for you to list the vertex of the original. So let's move on to domain and range. So the definition of domain is the set of all x values. So domain has to do with all of the x's. The definition of range is the set of all y values. So range has to do with the y's. So what we're going to do in our last examples is we're going to graph them and then state the domain and range. So example 5, we have y equals 3x plus 2 squared minus 5. So we're going to graph this just like we've been doing the whole time. So we start with the vertex. My vertex here is -2, -5. So let's graph that. That's at -2, 1, 2, 1, 1, 2, 3, 4, 5. So my vertex is here. My line of symmetry is at x equals -2. So let's draw the line of symmetry. And then let's actually draw the parabola. This is, our a is a positive number, so it's going to be going up. And it is not a fraction, so it's actually growing pretty fast. So it's going to be pretty narrow. So I'm going to draw it as narrow as I can, but it is going up. So since this is going up, it has a minimum at -5, the y value of the vertex. So we have all that information that we've been providing before. And now they want us to state the domain and range. So the domain, which we can use with just a D, is any x value that we can plug in and get a point on the graph. Now this graph goes on forever and ever, and it is growing, even though it's not growing out really fast because it's so narrow. But actually, this graph covers every single x value. We could plug any x value into this original equation and get a y value out. They might be very large, but we could do it. So we call that domain all real numbers, or we have that symbol for all real numbers. The range is a little bit trickier because since we have a minimum, there are no y values that fall below that minimum. That's the lowest point. So the range has to do with the y values, and every single y value on the graph is either bigger than or that one point is equal to the minimum, which is -5. So we write that as y is greater than or equal to -5 because all y values on the graph are bigger than or equal to -5. So that actually answers the question that they're asking in stating the domain and range. For the types of parabolas that we're going to be working with right now, domain will always be all real numbers because we can plug in any x value we want. We will get to a point where domain is not all real numbers, but for right now, parabolas that open up and down are always all reals for the domain. So example 6. We have -2 times x plus 3. And our vertex here is negative 3, and then we're missing the y value, but that's the same as saying plus 0. So it's actually negative 3, 0. So let's graph that. 1, 2, 3, and then a point here at 0. My line of symmetry is at x equals negative 3. So I'm going to draw that line of symmetry. And then my graph is actually going down because it's a is a negative, and because it's not a fraction, it's growing pretty fast. So it's going to be pretty narrow. Not as narrow as the previous one, but it's still going downwards. So this one has a maximum at 0. So when I'm looking at my domain and range, domain is the x values, remember, and domain means which values of x can I plug in and get an answer, and it's all of them, because we could plug in anything for x and we will get an answer out for y. So my domain is all real numbers. I can use anything for x. Range is where we're really limited here, because my highest value here for y's is 0. So all of my y values are either less than or equal to 0 because everything is going down. So that is our domain and range. Domain is all real numbers. Range is y is less than or equal to 0. And we have to put that equal to in there because we can be equal to 0 because that's a point on our graph. But all the other y values are smaller than 0 because it's a downward going parabola. So last example, example 7, we have negative 2x squared plus 20x minus 5. And this does not look like it's in vertex form, so we're actually going to have to do the old-fashioned way, which means we have to use x equals negative b over 2a, which is negative 20 over 2 times negative 2. So that's negative 20 over negative 4, so the x-coordinate is positive 5. And then we take that x-coordinate and plug it back in. So that's y equals negative 2 times 5 squared plus 20 times 5 minus 5. So that gives me negative 2, 5 squared is 25, plus 20 times 5 minus 5, which gives me negative 50 plus 100 minus 5. And then when I add all of those together, I get positive 45. So my vertex is positive 5, positive 45. So on my graph, I'm actually going to have to use a different scale than just one for each line. Along the x-axis, I'm still going to count by ones. But along the y-axis, I'm going to count by fives. So this is 5, 10, 15, 20, 25, 30, 35, 40, 45. So my vertex is at 5, 45, which here's 5, and 45 is all the way up here, which means my line of symmetry is at x equals 5. So I'm going to draw that. And then this is, the a term is negative 2, so it's actually going down, opening down, and it's pretty steep because it's not a fraction. So this has a max at 45. So my domain, I can still plug in any x I want. It just might take a while to get to some of those really large or really, really small x's, but I can plug in any x I want. So my domain is all real numbers. My range, on the other hand, has only to do with y, and all of my y's are actually less than or equal to 45 because I have a maximum here. So if you have a maximum, your range is going to be less than or equal to because that max is the biggest number you can have for y. If you have a minimum, like we did in example 5, your range is going to be y greater than or equal to something, because that's our smallest number. The minimum is the smallest y we can have at all. So that is domain and range. It helps to graph, but right now the main thing is to remember that domain, we are going to have all real numbers for the time being, and then the range is what we have to worry about, and that basically has to do with your minimum or your maximum.